And according to the timetable, in this lecture we are going to have the idea of MPPT boost charger and the boost closed loop using advanced C. So there is a demonstration of MPPT boost charger. We will discuss this in brief, and then after that we will move towards the simulation modeling and simulation of boost closed loop. So very first of all, when you double click on the software and you open the software, this window will appear in front of you at your computer screen. So what you need to do in this, very first of all, you have to go into the examples, and in the example you have to go into journal power electronics. Click on journal power electronics. Then there is a existing example of Typhoon Hill, that's boost converter with MPPT algorithm. Just click here, open model. Once you click on the model, the schematic of that particular model will get open in front of you. And when you open the first model for a day, it will take a bit time, and after this it won't take time. So this is a schematic diagram of MPPT boost charger. So for this, let me explain you the schematic of this. Then I'll show you, I'll run this model in virtual hill. Then I'll run it on the real-time simulator. Then we will see its SCADA panel. So if I make it zoom a bit, zoom, it will get more clear to you. What we are doing in this, we are having a setup of MPPT boost charger. So very first of all, we are having the PV photovoltaic panel which is available from our library. In this model, I am not going to drag and drop any of the components from our library, just because I am just demonstrating it. Then in the next example, let's boost closed loop with the help of advanced C. I will start drawing from the very scratch, and I will take the respective components and will design the full model. So very first of all, this is the PV panel which is available in our library. And yesterday in our Typhoon Hill introductory lecture, you will be get to know about that you have the detail of any particular component. If you want to know more about any component, you have to click on the help. Once you click on the help, it will redirect you to the help page of that particular like component. So this is basically the photovoltaic PV panel. And if you want to know more about this, you can go through the help icon of this particular component. So we have to take the PV panel, and we have initialized its capacitance, and then there is a current measurement, voltage measurement, to measure the current and voltage coming across the of PV panel. Then we have inserted a resistance and inductor also. Then we are having the boost uh, component which is available from the library core. It is exactly like there is an option of the internal modulator, detail inputs and model. This have already been taken by from the Khushbu ma'am yesterday when she was just demonstrating about the single phase inverter. So you must be having an idea of internal modulator and the digital inputs and model. I'm not going again on this. So this is that yesterday it was the single phase inverter, and likewise this is a boost converter which is available in our library. And here after this we are having one another current measurement, and the resistance and capacitor. Then we have I out. Then again uh, then again we have the then we have again a voltage measurement and current measurement. And when I just double click on it, and in the signal processing, we have taken the signal out by clicking on it, enable signal out. We have gone through it also yesterday. Likewise on V out also. And then we have taken multiplier, or I should say the product, and P we are taking the P out. of the boost converter. This is the main component, that is the battery, and we are going as the title suggests, MPPT boost charger. So this is the battery that is going to charge with the help of this PV and this boost. And then we are having two contactor with the resistance we have taken, that is one is the R load, and another is the R discharge. So this is basically the complete plant setup of the MPPT boost. So, as yesterday in the presentation, Madam has told you about the black component and the blue component and the green component. So, this black component in Typhoon Hill always shows the plant component, and these are its corresponding controller. So what inside this controller, what is going inside this controller, let me tell you more in brief. So this is the simple example of MPPT boost charger that we are going to demonstrate here. But in the environment of Typhoon Hill, in virtual environment and in the real time environment, I am going to tell you. So this is about the plant, and like this is for the P and O algorithm, the generalized perturb and observe MPPT algorithm. So, as you all know very well, this is the very generalized algorithm. Let me show you a simple, flowchart of this. Very first of all, we need to measure the V and I of a PV array, and this. Then we have to provide the delay. Then we need to compute the power, and we have to take the decision. So this logic is implemented in the C function. So now where is the C function? This one. So what is going in this? Let me tell you. Here from this we are taking the IPV and VPV, and we are calculating the power. And with the help of unit delay, we are processing it again. Now we are having the C function as the title of this MPPT boost charger using the C function. Here we are using the C function, and for the next example we will use the advanced C function. So at the end of the lecture you will be able to differentiate between the C function and advanced C function. So when I click on it, on the C function, uh, here there is an option of initializing input and outputs and variables and parameters. So here when I just click on it in the journal tab, we are having the inputs, and we are just taking power and voltage. Simply we have to write power and voltage. These are the inputs we are taking. Now outputs, simple, I have taken one output as out. And in the variables, we need to define some variables that will be processed in the function tab of the C function with the help of a basic code, or I should say the program. So the variable are duty cycle, delta duty cycle, minimum value, maximum value, and step. And this is about the journal tab. When I just click on this function tab, so the thing which I've shown you in the form of the figure right now, the simple is that this thing, this one, this we have implemented in the form of a code. And this is very easy to understand. A simple code we have written, like if power is less than zero, if power is equal to zero, double equals to, then the same thing that has been implemented in the algorithm, we are defining here. If power greater than zero, voltage greater than zero, then step will be equal to minus 1 into delta duty cycle. Same logic we have implemented with the help of a simple code. So there is a provision of writing a code in case of the simple C function. And what comes in the advanced C function, I will let you know after this. So the simple code we have written in this C function, it is like the like MATLAB embedded C function we use to write the code. It is like that only. So this is about the C function we are using. And here this is important to understand. We are taking some lower limit and upper limit, battery lower limit and battery upper limit. If we want, like if battery voltage will go below 49, then it will start charging, and if it will go up to 52, the charger will get stopped. This logic I'll show you in the SCADA. When I run my SCADA, this will take you about the concept what we are doing here. it is basically show the charging is as it is written, charging is disabled when battery is full, and the charging is enabled when the battery SOC drops up to 80%. So this is basically the logic that we have designed in our model, and this I'll show you in detail when I run my model in SCADA. Okay, so this is the basic or very basic or simple example of MPPT boost charger. There is nothing complex in this model, as many of you have designed this model and various tools like MATLAB and in some other tools also. I'm facing some disturbance from anyone. Could you please mute your mic? Yeah, thank you. Uh, yeah, again I'm facing. So this is basically the
Salim sir, please unmute your mic.
yeah. Am I audible now?
Yes, yes.
So, since when you were not able to hear my voice, I mean, was I clear on the schematic?
Yes, sir. Yes.
Okay,
Yes, sir, you were audible, sir.
okay, fine, fine, fine. So this schematic was clear. Now, I am, as I told, I am going to run this schematic on virtual environment first of all. Then I'll run it on the real-time simulator. So as I have just demonstrated about the plant and the controllers, we are going to we have designed and this. So let me run, very first of all, let me run in the virtual environment, then I will run it on the real time. Then you will get to know difference between the two at by yourself only. So simple, when I click on it, so the model is getting compiled, and now it is asking me unable to connect to the hardware device. Please select what to do next. Okay. So right, say for example, right now I am not connected with my real-time emulator. So I will load it on the virtual hill. I have clicked on the second option, and I have loaded the model on the virtual hill. The model is getting loaded on the virtual hill, and it SCADA will get open. After loading, there is an option will come in front of you, panels file found in model directory. So this, you have to click on it, single click, this model will appear in front of you. Okay, so this is the sorry, this panel will appear in front of you. This is the SCADA panel corresponding to that particular schematic. Okay, so now let me connect with my simulator, and let me switch on my camera so that I can show you the real-time simulator which is available with me. I need to connect with my mobile also so that I can show you. Yeah, let me connect, give me a minute. Mhm.